Okay, so we are doing second part probability. So tossing there is a formula. So for tossing 1 coin, 2 coin, 3 coin, 100 coins. So if we are tossing 5 coins, there is a formula 2 raised to power n. This you can remember because we have to know how many possible outcomes are there. Sometimes we are not able to write what are that outcomes, possible outcomes. Like here, you can write because there are two coins. If you have 5 coins, how will you write 2 raised to power 5 means 32 outcomes, head, tail. This will be first one outcome, 5. Then second like this, so it is very difficult. So we have the formula for coin 2 raised to power n. Similarly, not for all, but for some experiments, particular experiments we have for coin 2 raised to power n. Similarly, for die also we have the formula. If you are throwing one die, two die, three die, n dice. For n dice, we have the formula number of possible outcomes will be equal to 6 raised to power n because it has 6 faces. Coin has two faces. It has 6 faces. That's why its possible outcomes are 6 raised to power n. Okay, got it. We throw 3 dice. Is then we have 5, 3, 4, one outcome. Second outcome is 5, 5, no 6. This is 6, 6, 4, 3. Then again we can roll and we can get, so that is that we are getting 3, that was 5, sorry, 3, 6 and 2. So like this, all possible outcomes, if you write in a set, that is called the sample space. That is what called sample space. So we can say that is sample space and it is denoted by S. So S will be equal to this. All will be written in terms of set. Okay, so whatever times you are rolling. So all possible outcomes is rolling 3 dice. What are the possible outcomes? That are 6 raised to power 3. 6 into 6 into 6. That is 6 6 are 36 into 6. 6 6 are 36, carry 6 3 are 18, 216. So 216, this combination, how many combination you will get? 216 combination, like 1 2 3, 3 to 4, 4 to 1, like this. How many? 216. So it is not possible to write 216 possible outcomes, but we can find out the possible outcomes easily. What are the total possible outcomes? Because we have the formula for probability is we are finding the probability of an event. So event, the number of outcomes favorable to it, a number of favorable outcomes on total number of possible outcomes. Okay. Okay. So you said 52 raised to power something. No, no. For cards, there is no formula. For playing cards, there is no formula. For there are 52 playing cards, so there is no formula for playing cards. No formula. We use Excel in higher classes. You will see the combination, permutation, and combination. Okay. So that is. Then we have event whose probability is 1 are called pure event, and the probability of event 0 is called impossible event. So that we have already studied. Probability can never be negative. Probability can always between 0 to, that we have studied in class 9. It can be 0 and up to 1. Probability lies between 0 and 1. The probability of an event. So we have to find the probability of an event always. The probability of an event is equal to probability of an event is equal to number of favorable outcomes. Favorable outcomes. We used to write favorable outcomes to event. E means the outcomes which are favoring the event, whatever event or given. So the outcomes which are defining that event upon total number of possible outcomes. Total number of possible outcomes. Possible outcome. Okay, this is the formula for probability. And it is denoted, event is always denoted by E. So probability of E is equal to, we can write in mathematically, number of favorable cases. N E is what are the cases in event, the set of the event on total number of possible cases in a sample space. So we should know the sample space. If we don't know the sample space, we know what are the possible outcomes, like we have seen before. Okay, and for example, if we throw a die or coin, a coin is tossed. If a coin is tossed, find the probability of getting head. So here we can easily write what are the possible outcomes, head and tail. So number of total outcomes are 2. And event, what is the event here? Event is to getting head, to only head. So getting head is only one time, so n e will be equal to 1. So therefore probability of getting head, either you define e, you have to define e is what? Getting head. Getting head is defined by the event e, so that is why we can write probability of e, or we can write, instead of e we can also write getting head is equal to number of favorable cases upon total number of cases. Okay, so 1 by 2. And if it is asked in the percentage wise, so you can do 1 by 2 into 100, that is 50%. So in percent if asked, then you can convert, otherwise this is your answer, and probability will be always less than 1 and it will be always positive. And this is the happening of event, getting head. If you have asked not getting head, here I am taking the same event, this event. So probability of getting the head, P is the probability of getting the head. PE bar means probability in this event of not getting head. Probability of not getting head. So if probability of not happening the event, E is the probability of happening the event. Probability of not happening that event is always equal to, their sum is probability of happening an event plus probability of not happening that event, bar means not, is equal to 1. So sometimes it is also written P not E. Not E also can be written, or bar means same thing. Probability of happening an event plus not happening an event is always equal to 1. That means if we have to find, we have probability of happening an event, we can find the probability of not happening an event by using this formula always. Okay. For A and B, two possible outcomes of an event, for suppose there are two events for A and B, two possible outcomes of an event. two possible outcomes of an event. Then if probability of A, there are two events and probability of A, possible event, probability of A is greater than the probability of B, then A is more likely to occur than event B. Then A is more likely, and there are more chances of getting the event A, more likely to occur than event B, than event B. But if the probability of A and B are equal, so we are just taking the equally likely event. In our question always we are taking equally likely event. So PA is equal to PB, then A and B are equally likely event. Then A and B are equally likely event. Equally likely event or equally likely to occur. Equally likely to occur. For example, if we are just throwing a dice, so equally likely we can get 1, we can get 2, 3, 4, 5 and 6. Means the fair die. We have the fair die and this is called unbiased dice. Unbiased. If we speak of a coin, we assume it is to be fair. It is symmetrical so that there is no reason for it to come down more often on one side than the other. So we call this property of the coin as unbiased. So we are using unbiased coin or unbiased die or unbiased coin. Okay, got it? Always unbiased because equally likely event. We are considering all equally likely event. Okay, so understood? One thing that I want to explain you about the card, playing card. So I want to know how many of you don't know about the playing card. Just raise your hand. So number of how many number of face cards are there? King, Queen, and Jack. These are only three face cards. So each suit three face cards. How many suits you have? Four, so three, four, the 12. So there are 12 face cards. How many face cards are there? 12 face cards are there. Okay. So if the question is based on the face card, you have to consider a face total number of face cards. For example, question: if a card is drawn, if a card is is selected from a deck of 52 cards, from a deck of 52 cards, then find the probability of getting a red face card. A red face card. Okay. So total number of possible cases are how many number of face cards are there? 12. Okay. So there are 12 face cards here. So event is here number of possible outcomes NS is 12 And event is what? Getting a red face card. Event you should define getting a red face card. The number of favorable cases, red cards are how many red cards are there in phase two? Two, two, one king and one queen. Yes, you have red color. How many are red colors? Red and black. There are two types of red and black. So in red, diamond, diamond and heart are red, and black, spade and club are black. Okay. So we will have diamond. Diamond will have means red, three red. It will have three red cards, king, queen, and jack, three face cards. It will also have three face cards. So three plus three, how many? Six. So total number of red face cards are six, and total number of cards are 12. Total number of NS, not 12, sorry. NS will be 52 because we are taking from 52 cards always. So 52 out of 52 cards, we have to take out 6 cards. So therefore, the probability of getting this event will be equal to 6 by 52. 6 by 52, 2, 3 is 6, 226 the 52, so 3 by 26. Okay, 3 by 26. So you should know about all the face cards, club, diamond. You know that diamond is red color. It is like this. If you see the shape, this will be in the red color. This shape may be in vertical or horizontal. I don't think this is diamond. And heart is also red color. So this will be like heart only. This type of heart, and black color is not given here. Okay, spade. Spade is like this. You will get one figure like this. Spade. Club, you know that one tree like structure, tree like shape. So this is all club. So these are black color and these are red color cards. Okay. So I think we will continue next time. We will take from questions from our textbook and then we will continue.